Okay, so this is a fundamental question from chapter 25. This one is a little bit long just because there's a lot to do. So the first thing that I started off doing, or the first thing that you have to do is condense this down. So these capacitors are parallel capacitors, which means that their C equivalent is 4 microfarad. And if I come here, you can see that I have redrawn it, right? This is my C equivalent that I calculated up here. And this is my C4 that's still here. Okay, that makes sense. Then what I did was condense it even more because these are capacitors in series. So we can make one big capacitor from that. And that big capacitor, I don't know why you can't see the screen. There we go. And this big capacitor is gonna, this big capacitor from the series, use your capacitance equivalents for capacitors in a series, and I got a capacitor equivalence of 1 microfarad. And so this is my CEF. So now what do I do? Well, we know that the voltage across this is 1000 volts. And we know we have one capacitor now. So we find the charge on this one capacitor. And the charge is 1 times 10 to the negative 3 coulombs. I didn't write my units. I apologize. So what does that mean? Well, we know that capacitors in a series have the same charge. They all carry the same charge. They share it. That means that this charge is shared by C2, C4, and my C equivalent that we calculated up here, which is this. Okay, so what does that mean? That means that C2 and C4 have the same charge, 1 times 10 to the negative 3. And since they have the same charge, they're going to have the same voltage drop, which is, I'm sorry, they're going to have, they have different capacitance, so they're going to have different voltage drops, but they share the same charge. So for one, it's 2 times 10 to the negative 9, and for C4 is 4 times 10 to the negative 9. And we're done with the little ones. Now, with the big one, or with the one that we've condensed, we know that capacitors that are in parallel have the same voltage drop. They share the same voltage drop. This is important because we can just find the voltage for one and we'll have the voltage for all of them. So, right. So let's move from this step to this step, right? Let's go here. Your voltage is our charge over our capacitance, okay? The charge that we calculated for all of these was 1 times 10 to the negative 3. And we also know that the capacitance of this, right, is the one that we calculated up here, which is 4 microfarads. And 4 microfarads is 9 to the negative 6. So with this, we can find the voltage across this. And that's 4 times 10 to the negative 9, or 4 nanofarads. Or 4 nanovolts, my bad. This is voltage. Great. So now what do we do? Well, so now we know C1 and C3 have this voltage because they share it, because they're in parallel. So with this voltage, we can use the voltage and the capacitance to find the charge on each one. And that is what I did. And that is the answer.